Hello viewers, I'm Kausalya. Today we are going to solve problems related with the star network. The problem is a balanced star connected load of 4 plus J3 ohm per phase is connected to a balanced 3 phase 400 volt supply. The phase current is 12 amps. Find the total active power, reactive power and total apparent power. So here the impedance value per phase is given, right? It is 4 plus J3 ohm and the supply voltage is 400 volt, and here the phase current is 12 amps. So here what do you mean by a balanced load? A balanced load is one which will drag current, that is equal current in all its three phases, right? For example, if we are having R, Y and B in all the three phases, for example, if R drags a current of 10 amps, similarly Y will be also having 10 amps and the current flowing through this B will be also equal to 10 amps, right? This is known as a balanced load, right? So now we will proceed to find the active power, reactive power and the apparent power. So here this problem is based upon pure formula. Once you know the formula, you can easily calculate all the values, right? So here the first thing is, and again a key thing which is to be noted here is the value given in the problem, it is always RMS value, right? RMS is nothing but root mean square value here. So to find, you see the value of Z per phase is given. So here Z phase is, the net value is 4 square plus 3 square. So when you solve here, it is equal to 5 ohms, right? So then the formula for cos pi, that is power factor, is R by Z. So here the value of R is 4, right? So here it is, this is nothing but R plus JXL, right? So the value of R is 4 here. So 4 divided by, what is the value of impedance? It is 5. So 4 by 5 gives you 0.8. So from this, we are going to calculate the value of sin pi also. So pi is nothing but, when you move this cos to the right hand side, this becomes cos inverse. So pi is equal to cos inverse of 0.8, which is nothing but 36.86, right? So sin pi, so sin of 36.86 is nothing but 0.6, right? Now we are going to find active power, reactive power and apparent power. Here the formula for active power is root 3 VL IL cos pi, right? So root 3, here what is the value of VL? The value of VL is directly given in the problem, right? So 400 into the value of IL. Here in the problem the phase current is given, right? So what about the relationship between phase current and line current in a star network? They are same, right? Line current is equal to phase current. So here just substitute the values, and here the value of active power is 6651 watts, right? So VL, IL and cos pi is nothing but 0.8. So just substitute it and finally the value of the power is 6651 watts. Next, reactive power. So reactive power is given by root 3 VL, IL sin pi, right? So we know all the values, right? Root 3 VL, IL and sin pi we have calculated as 0.6. So here the answer is 4988.36 VAR. This is nothing but volt ampere reactive, right? And finally the apparent power. Apparent power is given by root 3 VL IL. So again here just substitute it and the final answer is 8313 volt ampere, right? So this problem gets over here. We will proceed with the next one. A balanced star connected load of 8 plus J6 ohm per phase is connected to a 3 phase 230 volt 50 cycles per second supply, right? Here also it is a balanced star connected load. Impedance per phase is given. Supply voltage is given. Find the line current, power factor, power, reactive volt ampere and total volt ampere, right? So here again it's the same thing similar to the previous problem. You see the value of impedance is 8 plus j6, right? So impedance per phase is nothing but square root of 8 square plus 6 square. So just substitute it and here the answer is 10 ohm. What is the value of power factor? It is nothing but R by Z. So the value of R is 8, right? Because here it is 8 plus j6, right? This 8 stands for R and this 6 stands for XL. So R is nothing but 8. So Z is 10. So 8 by 10 gives you 0.8. Again find out the value of sin pi. So pi is nothing but cos inverse of 0.8, which is 36.86. So sine of 36.86 is 0.6. Right. Now here the thing is, the main difference between the previous problem and this one is, in the previous problem the value of phase current is given directly. But here we need to find the value of phase current, right? So the other thing to be noted is the given voltage is always a line voltage. Okay, that is denoted as RMS in the previous problem. So whenever the voltage value is given in a star network, it should be considered as a line voltage, right? So here, now we are going to find the phase voltage because we know E phase and we know the Z phase, right? So here the E phase is nothing but EL by root 3. So the value of voltage given in the problem is 230, right? So 230 divided by root 3, the whole thing divided by the value of Z phase is 10. So once you solve here, the answer is 13.3 amps, right? So again in a star network, phase current is equal to line current. So this I phase is 13.3. Similarly, IL is also 13.3. Right. So now just substitute in the formulas. Active power or power is given by root 3 VL IL cos pi. VL is given in the problem. IL we have just calculated and cos pi also we have calculated previously. It is 0.8. So just substitute it and the answer is 4238 watts here. And the next thing is reactive power or reactive volt ampere. So here again root 3 VL IL sin pi. So root 3 into VL is 230 and IL 13.3 and again sin pi is 0.6. So here the answer is 3179 VAR, that is volt ampere reactive. And finally you see here the value of apparent power. So apparent power, or it may be asked as total volt ampere here, because you see the unit is volt ampere here, right? So therefore root 3 into VL IL. So again the value of we know everything, right? We know the value of VL and IL. So here just substitute the values and here the final answer is 5298 volt ampere, right? So here the main thing is, once you know the formula, you can easily substitute and calculate the final answer. So the main thing which you have to consider here is you should know how to calculate the value of cos pi and sin pi, right? And similarly, depending upon the problem, whether it is a star network or a delta network, you should carefully choose the values of VL and IL. Right, that's all. Once it is done, then it is very easy to solve these type of problems. That's all. If you have any doubt, let me know in the comment section. Thank you.